I'm a huge fan of the raw Kubernetes model myself, just because it gives you the ability to say, if it's a Kubernetes API of an equivalent-ish version, plus or minus 2 or 3 versions is usually adequate to make things work, I can run it anywhere. Right? I can take my application delivery model and employ it or deploy it into an environment and run that exact same system in any cloud provider or on my own self-managed, self-deployed Kubernetes. Hi, folks. Welcome back to the Kumulus on Cloud podcast. This is Robert Starmer, and I'm here with my fabulous co-host, Lew Tucker. Hello, Lew.
Hello again.
And today, I'm starting to feel like I'm just way too silly with this, but we're going to get talking about cloud again. But this is part 3 of our podcast series on Kubernetes. We're going to really talk about running Kubernetes this time. And over the past previous episodes, which you should, of course, go back and listen to, we first talked about containers and the importance of containerization and how that actually helped change the life cycle and the model for deploying an application. But of course, with that, we then realized that in order to deploy applications with containers, we still need a controller, a way to manage that life cycle, manage how things scale and shrink and change over time. And that's really where Kubernetes came in. And so in the second of the series, we talked about Kubernetes, a little bit about where it came from, but more importantly, what its value was, which was this whole idea of declarative, tagged, and of course, distributed control of containers and container systems. So with that as a background, we then, of course, have to figure out, well, okay, if Kubernetes is the answer, if that's the way that we really should be thinking about scaled out applications, not single containers necessarily. Today's answer, it's today's answer, not last decade's answer to how you manage controlled and scaled out applications. To me, the question is, how do we get started, right? What's the first steps to really making this viable for our business?
Yeah, and I think a lot of teams are struggling with that because, quite frankly, it is a bit of a mind, shift when you start thinking about declarative infrastructure and you start writing descriptions of what you want to have happen instead of making it happen yourself, which would be much more procedural. So the magic of Kubernetes, I think, is really it's a very simple, straightforward way to accomplish all of that, and it takes managing these resources that may be over tens or hundreds of servers and hundreds of containers makes it so much easier because you can manage them as a whole fleet and just simply say what you want to have happen with these things and how they're going to be self-healing, auto-scaling. All of those things can be done with the magic of Kubernetes.
Yeah,
but Robert, you've had a lot of experience helping customers approach this. How do you take traditional development teams forward into this world?
I think that's exactly it. How do you take a traditional developer and get them to understand that their life has just become easier? I find this is the part that really fascinates me, is that most developers don't want to operate their environment, right? We've talked in the past about DevOps, and DevOps is the answer for all things. I think DevOps is great for small teams, less than 10 people. DevOps is right. Everybody should understand how the application operates, and they should be working on their piece and make sure that it fits right into that operational model. Well, Kubernetes is the operational model, right? So now if you're a part of a 100-person company or a 1,000-person company, often you have never actually deployed your application, right? And the idea that suddenly you would have sort of a bit of control in where your application runs, how it scales, how it deals with changes, right? How do you upgrade or downgrade your application? It's not a 2 a.m. on a Thursday night that you've got a team that's trying to figure out how to get your app pieces up and running for you again, because you're declaring the state for that. And I think the biggest shift is the mindset of, okay, I need to understand what my operational model is without necessarily owning it. One of the downsides of Kubernetes is that there is a bit of a learning curve in understanding how to take a general application and get it containerized and then build in a container lifecycle model, just in terms of what that actually means. A lot of the developers that are actually deploying into Kubernetes in the end are still following I would call it now old school practice. I built on my laptop, and then I took that source code and gave it to somebody in test, and they recompiled it and then ran some tests on it. And then they gave it to somebody in operations who recompiled it and put it in a container and then put it into the production system. It's like, well, no, you guys missed the whole point. The developer needs to start with, I built my app into a container. Now, they may still build on their local laptop. I've struggled with trying to get people to say, do it all inside of a container all the time. You know, I'm not convinced I'm ever going to win that battle. But seriously, you know, thinking along those lines of, like you had said, it's a declarative system. So that's where you have to start. I know I'm going to declare the operations of my system. I don't have to handle it anymore. Isn't that brilliant?
Exactly.
Right.
And the container, once it's specified, I mean, that's why we have all the tools as part of your CI/CD system, how you build the containers to begin with. Then you can deploy that n number of times, and it's the same deployment every time you do that. So the idempotent model of a container is that it's fixed, and you can actually use it then over and over again, so that when you move it from one environment to another, you can be sure that you've got all the right libraries there. You're not going to have a difference in production than you had in development.
Oh,
there may be external things that make that difficult, but.
Oh yeah, I was just going to say that absolutely is the classic issue. What's interesting is that I've seen it at the level of a Docker container creation process also not working. Because you're at the time of creation of the container, you're building that bundle, you're building its embedded dependencies. And if you haven't, locked those dependencies down to very specific versions, or maybe those versions don't even exist anymore when you rebuild that container, suddenly, works for me comes back into the container development lifecycle. And if you're seeing that where works for me but doesn't work for somebody else, you've missed the point of containers, right? They are the bundle, they are the application that should go through your entire life cycle. So the other thing that I think is really powerful with that idea of declarative state is that it gives you another operations enhancement, which is, the developer can define the state of their functional system, right? And now you enable this idea of GitOps, right? I can manage the entire life cycle of my infrastructure and my application deployment on top by saying, this is the declared state that I want. I can check that into a source code repository. I can roll back to a previous version because it's not a manual process to turn these things on and off again, right? So anyway, I thought that was an important point to add in.
Oh, absolutely. Because I think it touches upon also how we see, we've talked previously about then on top of this, building a service mesh model. And that's where you're able to also, in a declarative manner, do things such as, traffic shaping and releasing canary deployments, releasing a new version alongside of the old version and shaping traffic between the two while you observe what's going on to see if anything breaks. So we start with containers, and then we have Kubernetes, and then on top of that, I think we have things such as service mesh and Istio. And all of that is designed to make the building, operating, and running of large-scale applications much, much easier, so that our development teams can handle these.
Oh yeah, no, I think you're absolutely right. The declarative engine is the core, right? That's what really drives the operational components. I think the other thing that we have to consider when you're trying to get people started, giving them that model, giving that a GitOps style flow, and giving them a template to build off of is probably the engine that makes this all so much easier. Kubernetes is actually, in my mind at least, it's really known for being difficult to get started with because up until, it sort of came and went and came back again. There really was not a good way to say, hey, this is a container image that I've created. Even more importantly, if I happen to have that container image on my local system, I'm basically out of luck with using that in a Kubernetes environment, right? So I have to start using distributed tools that maybe I wasn't used to using before, right? But it really forces you into a Git style, centralized, basically you commit your code, the code gets turned into a container. Now I can use that code for my tests because it is a known build process that generated that thing. And now I'm going to run it through all the rest of my stages. But by having created it remotely, I'm also going to store it most likely remotely in a container registry is the term that's used for that particular repository of code.
Exactly.
And
Right.
in doing that, now I have the ability to say the template can call that particular version or the previous version, right? Because I can now version all those different resources. So templates that drive that, but also templates that drive the build process, right? This whole idea of platform as a service where, well, not so much platform as a service, but platform engineering, right? Basically managing that templatized, consistent, repeatable engine, right? Now, what I find interesting is that once you've got a decent template for your app, all new apps can follow that template. You don't have to build new templates for every idea that you come up with. Brilliant.
Right. So it sounds like then there's got to be some productivity savings there as well, because you're having repeatable processes instead of manually going through. And the old days of running, shell scripts and things like that for deployment, hopefully are long gone. We've moved to this much more model where the templates and things like that can be kept in your own source repository. I mean, it can be, these Git repos and everything else where you can reuse that material over and over and over again. And it will change, but we always want to have then the whole history of those changes so we know what has taken place.
Well, I mean, if your templates are in Git and you're versioning your templates, then, if nothing else, you can always pull from a specifically versioned, well, I guess it's tagged in Git repos, right? So you can pull from a specific tag in a Git repo. That template is the one that we used for this production resource. That's a configuration parameter in your own resource, in your own Git repository for your application, right? So suddenly these things are all self-referential as well, and just because a new template's come out, maybe there are some security vulnerabilities that you want to recover from. But if I still need to deploy my old version for whatever reason, even in advance of deploying that, I can leverage all of that declarative state in managing what gets into production. What has or hasn't been tested, right? Because I don't want to just release untested code. Wonderful things.
And Robert, so what's available today for developers? I mean, would you recommend that they go and use, the kind of Kubernetes as a service that various cloud operators are offering versions of? Should they try it in their own development environment? Should they do it in-house?
I think we have a lot of different tools. So to first understand how Kubernetes works and start building a model in your own head for how to develop in a Kubernetes style environment, you can run Kubernetes on a laptop, because there's a Kubernetes in Docker. So there's a Kubernetes as a container. So it's the control plane plus the ability to launch another container image that can run in your local machine. There's a Minikube controller, another way of running Kubernetes on your local machine.
That's right.
And actually, Minikube is interesting because you can actually use it to run a multi-node cluster. So you can run Minikube on one machine and say, oh, now talk to another machine. Now I have two physical boxes or two virtual machines or what have you running it. So there are lots of ways to get started locally. But I find that unless you actually also want to run Kubernetes, because that's what we're talking about at this point, the thing that makes the most sense is to actually use a cloud provider. Google provides it, Amazon provides it, Azure provides it, Oracle provides it, IBM, Alibaba. I mean, you name the cloud provider, there is a managed. DigitalOcean actually has a really nice Kubernetes as a service, engine that's available to you. Right, so they're basically everybody offers this as a service, and actually with the bigger cloud providers now, you can also get effectively Kubernetes as a managed control plane. So you stand up in Amazon, for example, EKS, but then as long as you have the right connectivity, VPN connectivity, or now there's direct connections into the cloud providers as well. If you have a data center of hardware that's now potentially going to be going idle because it's not being effectively used, you can actually incorporate that hardware back into your system as well. So there are lots of ways of leveraging the Kubernetes system. On top of that, there's another layer that I think gets kind of interesting, because before Kubernetes, before even containers really became a way of doing things, there were tools like Heroku and Cloud Foundry and OpenShift. I think those were sort of the three contenders to the throne of platform as a service. The interesting thing there, and this was effectively the template that fully abstracted the operations, right? Heroku was, give me your code bundle and tell me what type of code it is so that I know how to run it. And then that's all I need to know from you, right? OpenShift and Cloud Foundry said, well, we can give you a different version of that if you want to run it yourself, or if you want to run it in a cloud provider and you don't want to have to work with Heroku explicitly. That was sort of there. So there are a couple of different models on top of just raw Kubernetes. I'm a huge fan of the raw Kubernetes model myself, just because it gives you the ability to say, if it's a Kubernetes API of an equivalent-ish version, plus or minus 2 or 3 versions is usually adequate to make things work, I can run it anywhere, right? I can take my application delivery model and employ it or deploy it into an environment and run that exact same system in any cloud provider or on my own self-managed, self-deployed Kubernetes. Although I'd probably go find a provider to help me deploy Kubernetes if I was going to do it locally, right? There are plenty of guys out there.
The software is obviously open source from CNCF, but again, there's sometimes it's sometimes helpful to either have the service provider manage that deployment, that control plane for you, or at least having somebody else help you with the understanding it and training of your folks and moving your current architecture into this, because it's not a small shift. I think this is sort of a big change from traditional either Java-based applications or whatever into something that is much more amenable to running as Kubernetes clusters.
Yeah, I mean, the process of taking an old app and reworking it to work in a scaled out Kubernetes environment is a task unto itself. That's a whole other topic that we could get into at some point. But, I do think, though, that, in order to get started, which was, I think, the idea that we really wanted to talk about here today, the best thing to do is to work with a cloud service provider. Most of us already have access to Amazon or Google or Azure Cloud. They all have decent models for running Kubernetes. If that's not appropriate, maybe you have a security concern or some other concern that you're just not quite ready to do anything there. There are providers. Red Hat, IBM has OpenShift, which is a Kubernetes. They've added some things on top, but at its base, you can still run raw Kubernetes deployments and infrastructure and services and anything you want within that kind of an environment. Canonical is another provider that has both an operating system basis and then the support and the ability to deploy Kubernetes at scale on that platform. SUSE with SUSE One and Rancher has another. I mean, there are lots of them out there.
There's lots of them out there. Exactly right. Yeah. Lots of different flavors. So where's all this going? I mean, we're at the point now. I think we're seeing Kubernetes very wide deployment, but then I'm also hearing things such as serverless and other models. In your view, what's going on? Where are we going?
I do think that the application development model. So there are tens of thousands or hundreds of thousands of developers that are, I would still call them old school developers. They live in a monolithic world. They've been managing maybe even older applications that run businesses. So there's a lot of work in sort of refactoring all those applications into a containerized, operationally more scalable fashion, right? Some of those will be wholesale rewritten. Others will continue to be maintained like the COBOL environments on mainframes for years to come, right? But I think for new development, for systems that are being architected now, there's the new client server model is that the client is a web application that can run in any JavaScript enabled, I guess there's a web VM now, right? So you have a virtual machine that can run anywhere. But that virtual machine is effectively a containerized application or even a containerized process, because even with Golang today and Rust and some of the other languages that you can compile, you can actually create a container that is a singleton. There's nothing else in it except for the application, right? So I think we're seeing pieces of that. I think the control model, which is where Kubernetes fits in, actually, to me, that's even where serverless fits in, right? That control model is changing. Serverless is an interesting way of dealing with the life cycle of your application component, right? Because it shows up when it's needed. I think one of the areas that we had briefly touched on was effectively AI, both from the application development and delivery perspective, right? Hey, now people are talking about using ChatGPT to write their code. Okay,
helps me write code now.
Yeah, so it's like that part is brilliant. But then also the life cycle of your application. Right now, we still have to do a lot of thinking about, okay, how do I want it to scale? What kind of signals am I using to determine if something should scale? If I could have an AI engine help me make sure that my application is delivering the best performance to my customers at all times, I think that's something we're definitely going to see, right? the world of optimizing your cloud. And I think our first podcast was on cloud cost and how people are
Exactly
frustrated
right.
by the fact that this is expensive. I think that's another area where, AI tools will be coming along. We are going to see them, if we haven't already, that can say, yeah, we can look at exactly what's going on in your system and find optimizations that you never would have seen. Right. And I think that's a large part of it.
I agree. I think that's got a very bright future in terms of lots of developers and different companies that are looking to apply the kind of AI processes around these kinds of things, particularly when it's managing infrastructure, because I think that's a low-hanging fruit. People spend a lot of time and a lot of human resources on that, and they could use some of this assistance from these AI systems that can monitor and detect anomalies and find something that isn't behaving as it has been behaving in the past. So I think the future is very bright.
Yeah, I mean, it's the expert system that we've been talking about for 40, 50 years. Finally, there's finally enough computational power and there's enough going on that we can actually discover from that. I mean, that's why ChatGPT works, right? Because they have a lexicon of billions of lines of English, that they dumped into this thing, and that's why it writes English. And the English teachers go, I can't tell this from that,
And it knows Python. It can read
and
Python
it knows
too.
Python. I mean, mind explodes, right? Actually, I need to ask it some React questions.
Exactly.
No, I think the future is bright for developers. Actually, the big thing I think that's going to happen is that more people are going to be able to develop, because there's going to be a better way of translating an idea that you have in your head into a functional tool that can help you get something done. And that is exciting.
I agree.
Right? So, well, great.
That's where we really need these smart assistants.
Oh, absolutely. Yeah. It's like that's what I want. Help me figure out how I get this idea in my head into a thing that can help other people too. Right. That's the brilliance of I think our machine learned and AI driven future, hopefully. Great. All right. Well, hey, this has been Robert Starmer, and I'm joined here with my fabulous co-host, Lew Tucker. Lew, thanks again for your time today. I think this was
great to be here.
Yeah, excellent session. And don't forget, check us out on the web, kumul.us. If you haven't subscribed, subscribe to this either on YouTube or on your favorite podcasting channel. And don't forget to share and like and do all the good social media-y things that we need in order to let us keep coming back to you and keep doing these sorts of things.